Oke guys, selamat dari Bujaya guys. Ini adalah fenomena penampakan petir merah atau petir red Sprite. Kita nontonin aja tontonan video di channel Lepal. Oke.
On rare nights with clear visibility over powerful distant thunderstorms, right, you might be able to see and capture red sprites.
I saw that one too. You saw that red one?
Yeah. Sprites are large-scale electrical discharges occurring high above thunderstorms in the upper atmosphere.
Bam, there's a sprite. Bam, bam, bam.
They come in clusters. They are massive events. Sometimes 50 kilometers tall by 50 kilometers wide. They belong to a mysterious and colorful group of phenomena called transient luminous events, or TLEs. Other TLEs include halos, elves, secondary jets, blue starters, blue jets, and the magnificent gigantic jets. But what exactly are these transient luminous events, and how do they form?
Yes!
In 2019, I teamed up with one of the most successful TLE photographers in the world, Paul Smith. Our objective was to simultaneously document TLEs from different locations to help us understand and capture them better.
Boom! Whoa! Yeah, right there.
We didn't know what we would find, if anything.
Nice falling star.
But we never expected to discover a new TLE. In this video, Paul and I will summarize current scientific understanding of red sprites, as well as showcasing some of the most rare and amazing captures ever recorded.
Itulah keren, jadi petir red Sprite atau inilah petir merah.
Visual reports of transient luminous events date back several centuries. It wasn't until 1989 that the first ones were accidentally caught on camera. Years after discovery, they were named sprites for their spirit-like nature. In a recent video, we showed how one lightning flash can abruptly change the electric field, triggering a secondary flash in a sort of domino effect. Sprites are also initiated by a large electric field change that occurs during a massive horizontally extensive lightning strike far below. These parent flashes transfer huge amounts of charge and are almost always positive in polarity, meaning that the Earth rapidly gains a net positive charge from the strike. But pools of positive charge near the tops of thunderstorm complexes also change, abruptly gaining negative charge. This suddenly creates a powerful electric field between the tops of thunderstorms and a high concentration of positively charged ions existing 100 kilometers or so up into the lower ionosphere. It's this new imbalance that can initiate a sprite. On June 22, 2019, Paul was documenting sprite activity over a thunderstorm, while I simultaneously documented their apparent lightning activity under the thunderstorm.
Boom! Whoa! Yeah, right there.
Did you get a sprite with that?
That's some sprites.
Oh, no way!
Yeah, man. Boom! There. That wasn't a big sprite though. That was just a little column. Boom! Yes!
Awesome!
Oh, yeah,
Gotcha! With every horizontally extensive positive ground flash I observed under the storm, Paul observed a sprite above the storm. On occasion, a cloud flash will have one end of the leader exit the upper extent of the thunderstorm and propagate toward the upper atmosphere. The rarefied air and low pressure of the upper atmosphere leads to a visible transformation in the leader as the ionization travels upward. This is how blue jets form, as well as the magnificent gigantic jet. Sprites are often incorrectly referred to as upper atmospheric lightning, but lightning temperatures are much, much hotter. Sprites are considered a cool plasma phenomenon.
Whoa!
The physics that causes sprites to briefly glow red is much like the process that causes the auroras. When energy in the form of speeding charged particles collide with atoms in our atmosphere, that energy is transferred, causing the atoms to become excited. As they calm down, they can release some of that energy back into the atmosphere in the form of light. Each element has a unique emission spectrum that acts as a fingerprint, identifying the guilty culprit. In other words, we can identify what element is being excited by the color of its light emissions, just like you could with a Bunsen burner in your grade school science lab, assuming you weren't raised in a barn. Oxygen tends to give off mostly green light when excited, and nitrogen, reds and blues, depending on the atmospheric pressure and other physics. The energy particles that cause the auroras to glow come from the sun and arrive in storms of solar wind we call geomagnetic storms. With sprites, the energy is generated by the powerful electric field between the thunderstorm and upper atmosphere. Auroras occur way higher than sprites, up around 100 to 500 kilometers in altitude, where the atmosphere is mostly molecular oxygen. As mentioned earlier, the excitation of oxygen emits green light, and that's why the auroras are mostly green. But in some really strong auroral events, you can see pinkish fringes along the bottom edge of the green aurora. And that's usually where the high energy particles from the sun have penetrated way down in our atmosphere, where there's an increasingly higher percentage of nitrogen, right around the 100-kilometer altitude, right around the top edge where sprites reach. Sprites occur around 40 to 100 kilometers, and at these altitudes, the atmosphere is mostly nitrogen. Remember earlier that the excitation of nitrogen emits blues and reds. Right. At the atmospheric pressure sprites occur, nitrogen excites red, but as the pressure increases the closer you get to Earth, nitrogen excites more in the blues. Sometimes a large sprite event can trigger a second TLE. We call these secondary jets. Secondary jets become visible near the tops of thunderstorms, where nitrogen excites in the blues, and extend upward to altitudes where nitrogen excites more red. In a photograph of a sprite in secondary jet event, you can see the gradual transitioning from blues to reds as the pressure quickly decreases in altitude. Ooh, yeah! That's right! Yay! On May 25th, 2019, I was documenting a vibrant sprite storm over Oklahoma and captured something I've never seen or heard of. It's spriting like crazy. This is so awesome. After two large sprite events, a mysterious green afterglow appeared. It seemed as if the sprite had triggered a small aurora. Early that next morning, I called Paul to discuss the strange captures. He was the first to agree it was something new and hypothesized that it was likely oxygen being excited. For the next few weeks, Paul and I shared this strange discovery with scientists, as well as the public in various weather threads, trying to ferret out an explanation. Nobody had ever heard of this before. Paul scoured through his extensive archives and found a similar event, and storm chaser Scott Kearns did as well. But both examples were too low resolution and too faint to give much support. Many people argued it was a camera sensor artifact rather than a natural occurring phenomenon. Weeks later, though, Paul silenced the skepticism with several deal-sealer captures.
The night of September 24th, 2019, there was some big storms over central Kansas. I was getting a few sprites earlier in the night, and then all of a sudden, with this really big, bright lightning strike that captured this monstrous sprite, just one of the best sprites I've ever seen in my life. It's got all of the colors that can be involved in TLEs, ranging from the pinks down to the purples in the lower atmosphere with the reds at the top. And then upon closer review, I could see that I got a really good example of this green tops of the sprite that I'd seen hand captured before. So I was pretty excited about that. And then just an hour or so later, I also caught this set of dancing sprites where sprites were firing in succession. The last sprite in that series was really strong and left a really, really good example of the green afterglow when it was done. So I was really excited that night to capture some of my own high contrast green afterglow events. Not too much longer after, just a month later, I was shooting over towards Arkansas and I started getting really strong sprites, and a couple of these I was also getting the green afterglow.
Wow, and green!
So this is when I started getting really excited, thinking, well, Hank's caught something here and now I'm getting them too. This is something that's really happening up there. I decided to go online and look through some archives of other people's captures. As you can see in some of these, we got these really big, powerful sprites with what looks like a green tinge on top. So maybe these sprites we're seeing with the green tops are stronger sprites where the oxygen is getting excited at a higher level, and the glow from that oxygen is lasting longer than the glow from the nitrogen, which would be red.
Keeping in the theme of sprites, trolls, and elves, we are referring to these green emissions from excited oxygen and sprite tops as ghosts.
I'd like to send a colossal thanks out to Paul Smith for sharing his amazing captures and knowledge with us.
Yeah, thanks a lot, Hank, man. Thanks a lot for having me. I'm just really pumped to have somebody that's excited about this as I am, and I can't wait to see what we capture going forward.
Yeah, man, it's extremely rewarding that even in this age of there's nothing new under the sun, ordinary people can still go out and discover something no one has ever documented before. Thanks for watching, everyone. Be sure and check out Paul's YouTube channel to